Hello, and welcome to the Norwegian parallel session on digitalization. My name is Helen Roth. I am CEO of VIA, Vital Infrastructure Arena. Now I'm going to share the presentation with you. Just first, VIA is a member of the National Cluster Program of Norway. We have as a vision to be a global leader in smart, safe, and sustainable transport infrastructure. VIA is an association with around 100 members from private and public sector. VIA is working on innovation and research and are trying to stimulate the partners, members, and also the tunnel community to work on renovation and research and innovation to do renovation in a better way. In this parallel session, there will be the possibility to ask questions. Then use the chat in the open air system. As a cluster, we are working in several projects, and one of the projects we've been working with is a virtual tunneling project where we have developed a prototype of a virtual tunnel. The overall scope in this project is to develop a digital twin that might be used for training, education, innovation, and research. Our challenges, lack of accessibility. It is not easy to get access to a tunnel when opened to do a scan. And also lack of resources. It is expensive to make a scan of a tunnel. We have a prototype where we have 330 meters of the Ryfylke tunnel as a virtual tunnel. Just to do the scan costed around 70,000 euros. And then again, we needed another 70,000 euros to build the prototype in virtual reality. So I'm starting this parallel session by giving the challenge to Naeem Khademi at the University of Stavanger. Naeem, would it be possible to generate digital models of tunnels in a more efficient and reasonable way? Naeem.
Thank you, Helen, for the good question. I think I would say in short, yes, it is possible, and that's going to be the subject of my talk that is coming next. So with that, do you want me to move to my talk?
Please move along.
If we can have it on a full screen, that would be great.
And if you have questions for Naeem during this presentation, use the discussion forum. If there is time, I will put forward one of the questions to him in the end. Otherwise, he will be able to answer them later on. So go ahead, Naeem. The floor is yours.
Thank you very much, Helen, for the nice introduction. So as you know, my name is Naeem Khademi. I am an associate professor of computer science at the University of Stavanger. And today I'm going to talk about ICT-based tunnel safety. And with that talk, I'm going to also take up one case, which is about the procedural and parametric 3D modeling of Norwegian road tunnels. It's an activity we did within the Kapasitet Luft Tunnelsikkerhet, Capacity Boost Tunnel Safety Research Group. And we conducted this activity in that project in the ITSRG research group, the ICT-based tunnel safety research group at the University of Stavanger. So let's look at the road tunnel safety in general. And so this field has always been a multidisciplinary field. It's always involved several different domains, from psychology to civil engineering, medical research, physics, computational, fluid dynamics, fire protection, emergency response. But all of that has been revolving around the area of safety and risk management as the anchor of tunnel safety. when we study tunnel safety, we should consider safety into account in different phases, including the design, construction, operation, and maintenance. And also we should consider multiple entities, multiple vantage points. How does the safety looks like from the vehicle's point of view, from the central traffic center, emergency responders, the tunnel infrastructure, and the road users. So when we study safety, we look at this interaction between these different entities. With that, I would like to open a conversation about the latest trends in the ICT. ICT here is standing for Information and Communication Technologies. As you probably know, in the last few years, there has been a significant progress in the ICT field. If you just look at the last decade, what you will notice is that there has been a progress in the field of artificial intelligence. We have better AI algorithms, softwares, and more capable hardwares for doing the AI, machine learning, deep learning. We have better sensors. We have varieties of sensors that could be used in tunnels, the IoT sensors. And once we have those sensors, we end up having a lot of data that we can capture from these sensor networks, and also monitoring data. And we could aggregate those and analyze them and make sense of them. That is what we call the big data. Also, we have much more advanced communication technologies in the last years. These communication technologies are better suited for mobility and for Industry 4.0. For instance, if you look at the upcoming 5G technologies, you know, the vehicular communication is coming, the V2X communication, or the massive machine type communication. We have a range of communication protocols for the industrial devices, IoT devices, vehicles that is coming and emerging. In addition to that, we have better information models and better presentation tools. We could make use of virtual reality, augmented reality, mixed reality, all together called as extended reality. We have better building information models, or BIM models, that could be used in the tunnel industry, and with all of that, we could have tunnel digital twins. So and that's the way we can basically make sense of the data, and also storage and analyze the data, and also present it. So with that, I would like to define a term which is or coining a term is called the ICT-based tunnel safety. Basically, it is about applying ICT-based solutions and technologies to the traditional tunnel safety work and aiming for Tunnel 4.0 or a smart tunnel. How do we pursue this? In our project, we pursue this in the CATS project and in the ITSRG. What we would like to do, for instance, if we look at the case of a digitalization, digitalization is more than just archiving data on online platform. It's also to dynamically aggregate, process, analyze, and make sense of big data in real time and automated way. Once we have that, a good sort of tool for digitalization is the digital twin tunnels, or DTTs. This is an activity we are pursuing, and we have already submitted a proposal to the EU that was proudly rejected, but we are hoping to follow that up, and we would like to have a similar idea for digital twin ideas for the tunnels in operation. So Helen talked about digital twins. How we can make digital twins? A prerequisite to the digital twins is to have tunnel 3D models. If we can categorize the tunnel 3D models into 3 categories: low, medium, and high fidelity 3D models. Based on the use cases, each of them might have their own use cases, basically, their own basically scenarios. The high fidelity 3D models are relatively expensive to produce, as Helen mentioned. Why? Because we need to make use of laser scanners or LiDARs, or the high resolution 3D cameras. We need to go inside the tunnel normally during the maintenance time, and do the laser scanning. And also, once this scan is over, then we need to do the object detection and the classification, identify what we are seeing inside the tunnel using deep learning and image processing models. So this costs a lot, and it therefore covers very few tunnels, normally the big or high traffic long tunnels. However, there are many use cases where a low to medium fidelity 3D model could satisfy our use case requirements. For instance, in case of emergency responder training, we don't need to have a millimeter level accuracy 3D models. Use evacuation apps. So the low to medium fidelity, it's still very useful for us. And if we want to develop these models, the manual CAD design, it's quite boring and cumbersome process. So the question is, can we have a parametric and procedural way of producing 3D models in the low to medium fidelity category? So to answer that question, I would like to mention an example of an activity that we did. And I would like to highlight that publicly available data banks, they can be extremely valuable resources. For instance, the Norwegian road authorities, they are maintaining a national road data bank referred to as NVDB. And in that road data bank, you can find all the information about different roads and tunnels and agents inside them. It's a client-server model, basically, and it supports two main data serialization formats, such as JSON and XML. So what you normally can do is to basically make a query using this NVDB API and get tunnel metadata, such as the tunnel profile or length or coordinates of the central points of the tunnel along its path. The child objects of this tunnel object could be sensors, cameras, antennas, any other objects, boxes that are installed inside the tunnel. All that are stored in the NVDB API in the text format. It's in XML or JSON, and can be shown on the map, as you see on the right figure. However, what we have done basically the first quarter of 2020, we developed a procedural, parametric, and fully automated and a scripted software model that can generate any given Norwegian tunnel in 3D based on the NVDB database's public data. So we wrote a Python code that was using the Maya 3D. And the way that this code works, this software, is that it makes queries to the NVDB and gets responses about each tunnel. As you see in this query, you get to see the profile, the tunnel profile, and you also get to see the coordinates, the central coordinates along the tunnel's path. What we have done, we have developed 3D models of different tunnel segments for different profiles. And once we have a tunnel segment per a given profile, what we can do, we can stitch them together according to their coordinates. So using the NVDB query response and the tunnel profile 3D segment, which we have developed ourselves, we could also construct the entire tunnel's 3D model, which we have done, as you see in the figure in the center. And then once we do that, we can import it to a virtual reality environment, such as the Unity 3D, as you see on the right. And so what is the ongoing activity? This is very interesting because we did not spend any money on this, basically. We could produce pretty much low to medium fidelity 3D model for any given tunnel in Norway. Of course, it's not perfect. There are corner cases. For instance, there are some areas where you might have basically missing data in the NVDB database, and you might need to find workarounds around it. What we have been doing so far, we have been putting objects in it in an automated way. So to do the automated object placement, adding lighting and textures, interactive objects where we could actually, in virtual reality, someone could open a box and pick a fire extinguisher, develop complex geometry such as tunnel roundabouts. And we have two near-term use cases for this. So the one is that we would like to develop a firefighter VR training app. And the firefighting stations, they need to be trained against the tunnels they are in charge of. Nowadays, the way they are trained is that they go to a virtual reality arena or an actual tunnel. And in the virtual training scenario, they are basically trying to train against a very generic tunnel. So in this case, we can give them the tunnel. We can give them the tunnel that they actually are in charge of. So if they are in a particular geographical location, we can just give them the tunnels that they are basically in charge of, and they will be training in that. Another is to have a tunnel safe rescue mobile app that would basically show the exit signs, and when you have smoke inside the tunnel, you could pull up your phone, and then using this app that uses our software, we could basically find out where to go. So the road users could basically do the self-rescue. And the long-term plan here is to actually integrate the BIM models inside this, and also to interface this with external API for sensors and SCADA systems, such as the OPC UA API, and eventually move this into a digital tunnel twin scenario, and end up establishing a very parametric procedural way of producing digital twins for any given tunnel in Norway, and in a very cost-effective way. And so with that, I would like to conclude. And so my conclusive remarks, basically what we saw is that there are new opportunities that arise from the ICT-based tunnel safety, and that would pave the way for a smart tunnel or tunnel 4.0. The enablers in that is basically the new AI mechanisms, machine learning and deep learning, the big data, Internet of Things, augmented and virtual reality, and also a range of novel communication technologies such as 5G and the sensor networks. We also saw that in our use case that making data publicly available, that is significantly important in the digitalization process. It enables us to do things that we just did, which would not be possible if the NVDB data wasn't publicly available. To know where the objects are, how the tunnels look like, where are the coordinates. And when doing that, when we make the data publicly available, it's important to adhere to the privacy rules, to the GDPR, and also consider the cybersecurity meanwhile. But these should not stop us from releasing the data publicly. So a lot of data can already been published publicly that we could make use of. A lot of researchers could do a lot of innovation on them. Eventually, the digital twin tunnels, they can be very valuable for tunnels in operation, such as for monitoring. We could basically track the activities and mirror those activities, what is being sensed in a tunnel, into a digital environment. And that is very useful to see the tunnel as a whole, not as smaller segments, and to make sense of data as a whole in a digital twin environment. And also it's very useful for maintenance, for asset management, especially if it's combined with the BIM models and databases. We could keep track of the assets as they change, as they basically get updated within a tunnel, and have a full picture of the status of the tunnels over time, over years, once we are able to establish digital twins. And so this is a move towards that direction. And with that, I would like to end my talk. And if there is any question, I would be happy to answer.
Thank you, Naeem, for a good presentation, and also being on time. Even a minute before time. I have one question from Ton van Tintelen here, and he is asking, how can a tunnel manager cope with all these new ICT technologies? They have to keep them running for the life cycle of the tunnel.
Yes, that is very important, and that's where these ICT-based tunnel safety research groups come into play. So what we have done in the academia, we have established a research group that works in the department of the safety, and also, but the base of it is in the computer science department, basically looking into the ICT scenario. So it's important to have the dialogue, right? I don't expect a tunnel manager or a monitoring, a VTS or the traffic central monitoring to actually spend doing the time to do the innovation work. But it's important to have the dialogue, to be exposed to these new possibilities. And how we can figure those possibilities is to openly share the data as much as we can with the researchers. and also to basically build the capacity. That's basically what our project is doing. The CATS project is trying to do, is to build the research capacity in the area. So I guess I hope that I covered the answer to that question. If there's any more questions, so could your system be used in other countries? What are the data prerequisites? We have developed a system that is using the NVDB, the Norwegian public road database. But we could port that into any other road database as long as you know the tunnel profile and know how it looks like, and as long as all the data is stored somewhere in the text format. So let's say if the Dutch version or the German version have their own sort of way of storing the data in a public database where they have the objects, the tunnels, the road infrastructure information, we could change the software to be adapted to that. So it's possible to make forks of this software. Yes.
I have one more question for you, Naeem, before we have to move on to the next room. You use public available data. How do you verify? Be sure it's the correct data. This one comes from Erik Meyer.
Yes, so that is, we have to rely on the NVDB data. But what the good thing about our model is that once you visualize this, then you see, oh, there is something out of the place, right? Or that our algorithm sometimes, if there is the missing data, we could check against it and we can identify it because we see it's missing. And so we can identify if either visually or through the script that we have written, and inform the road authorities that, this data field is missing, or this is maybe incorrect because it visually looks wrong. And so it is actually maybe a good side effect of having such a software, because once you parse that data and if your code breaks, then you zoom into what made the code break. And sometimes you have to do workarounds just so that that it works. But we have come across these cases where the data was missing or it was wrong, and we identified it, and we could convey that to the road authorities and people who maintain the database that this is a missing data item, for instance. Yes.
Thank you very much, Naeem. I think we have to stop here because we have to give everyone time to regroup and move on to round two. Round two will start in 2.5 minutes. So
yes.
Thank you everybody for listening into the first presentation of this parallel seminar. We will move on with the next next presentation in just 2 minutes, but then you have to leave this room and go into the new parallel session meeting room. So I'll see you in just a couple of minutes.
Okay, thank you very much.
Thank you.